From the ideal impulse response equation using the Fourier transform, we note that sine omega Cn divided by pi n is a sine C function. So based on this omega Cn function, it is equal to n pi or pi n. Therefore, omega C is equal to pi. This equation is equal to sine C function based on this one. Sine omega Cn divided by pi n, where pi n or n pi is equal to omega Cn. This function is equal to sine C omega Cn, where sine C x is equal to sine x divided by x. So sine C function of omega Cn is actually equal to sine omega Cn divided by omega Cn, where omega Cn is equal to n pi. So this equation is equal to sine C omega Cn, where this function can be described in this figure for ideal impulse response signal. For design impulse response, it based on an ideal frequency response where it is unrealizable because of non-causal and unstable. So it is necessary to relax the ideal constraints on the DTFT, discrete time Fourier transform frequency response based on the magnitude, and allow some deviation. This is the deviation from the ideal response. Therefore, the specification for the low-pass filter and its respective impulse response, where we need to shift it to the right by alpha and duration limited by a window, will typically have the following form. So based on this equation, the magnitude of ideal impulse response HID must be between this range, larger than 1 minus delta p, where this is the deviation, and equal or lower than 1 plus delta p, the deviation. For frequency, between 0 and omega p. Otherwise, for frequency larger than omega s and lower than pi, the ideal impulse response magnitude must be equal or lower than delta s, the deviation. So for design impulse response, we need the impulse response to be shifted to the right by alpha. So the impulse response HD, the desired impulse response, is equal to sine omega C with the shifted to the right by alpha, n minus alpha, divided by pi n minus alpha, where this one is shift to the right. And then we have the duration where it is limited by a window. For Hn, it is equal to Hdn, the desired impulse response, multiplied with Wn, the window function, for n larger than 0 and lesser than n. Otherwise, it is equal to 0. Alpha is a constant phase delay and equal to half of filter coefficients, where alpha is equal to n divided by 2. And Wn is a window function with a duration of n points.